everybody? Who's ready to do some derivatives? Okay, so we have done the power rule and variations of the power rule where we need to rewrite. We've looked at sums and differences, and we've looked at our buddy e to the x, who's the best derivative ever. What we want to start looking at in this next section is what happens when we have a function that is either a product or a quotient. Unfortunately, products and quotients don't play nicely like sums and differences do. That would be too easy. So we have rules for products and a rule for quotients that you just have to memorize so that whenever you see a product or a quotient, you follow that rule and you get the right derivative. You cannot just take the derivative of the two things. Sorry. Okay, so here's the product rule. Now I'm going to show it to you in map speak, and then I'll show it to you with hearts and clouds. It'll make you feel better. Okay, so here's the product rule in math speak. It says if u and v are differentiable functions, in other words, I can't take a derivative if I don't have a differentiable function. Their product is also differentiable, and here's the rules. Okay, now this is the same rule written twice, just in the two different notations. So in the top rule, they're saying, notice here, I'm taking the derivative of a function, and the function that I'm taking a derivative of just happens to be the product of two things. The first thing they're calling u, and the second thing they're calling v. Okay. The rule over here, notice, has two terms. In the first term, u stays the same as it ever was, and then it's multiplied by the derivative of v. In the second term, it's the exact opposite. It's a flip-flop. V stays the same as it ever was, and it's multiplied by the derivative of u. Okay. Now, this rule looks a little more difficult in this particular notation. A lot of people prefer this notation, the prime notation. Again, it's written the same way. U times the derivative of v, and v times the derivative of u. I think of it as first derivative of second, second derivative of first. That's how I have it in my head. Now, I have noticed over the years that a lot of people do it opposite of me. They'll write this VU prime term first. Doesn't matter. It's an addition. So the order in which you write them doesn't matter. What's important for the product rule is that you get two terms. Each term is going to have one piece of the product untouched and the other piece of the product having had its derivative taken. Okay, so for those of you who think this looks like too much and you like the hearts and clouds, here it is. Okay, so I have two functions. One I'm calling heart, one I'm calling cloud. Listen, this might be an x squared and this is an e to the x. This could be a sine x. This could be a big old polynomial. We don't know what these two things are going to be. The idea is this: I don't care what they are. When I go to take the derivative of two things that are being multiplied together, I follow this as my guide. I'm going to take my first thing, I'm going to multiply it by the derivative of my second part. Then I'm going to take my second part and multiply it by the derivative of my first part. Okay, so we're just going to do a couple practice problems following this rule. This is a rule that you will eventually just do without even thinking. It'll just be, that's a product, let me go do it. All right, so the first example that we're going to do is a little bit ridiculous because you don't actually need the product rule for this, but I want to prove to you that it works. So if I gave you this problem, I would fully expect, if I can find my pen, come on, Granny, I would fully expect you to rewrite this as 4t to the 7th and then just use the power rule on it, right? If you did that, you would get 28t to the 6th and call it a day, and you would be correct. All right. But why would we do that when we could go out of our way to use the product rule? Right? I want to do that because I want you to see that the product rule does indeed work, and it's kind of neat. Calculus never ceases to amaze me. Okay, so if you want to call them u and v, then some people would come under here and they would say, I'm going to call this u, and I like to put a squiggly line, and I'm going to call this v. I personally don't really like u and v because they look the same. So if you want to call it heart and cloud, you could do that. Like sometimes people literally come in here and they put like a rectangle around one and a cloud around the other to visually separate them for yourself. Okay. Now, what you might want to do, especially in the beginning when you're learning this, is go off to the side and write down what your four parts are, and then all you have to do is come back and put it together. So for example, my u, or my rectangle, whatever you want to call it, is t to the third. So therefore, my rectangle prime, or my u prime, whatever you're calling it, is 3t squared. Same thing for my cloud. My cloud is 4t to the fourth, and so my cloud prime, or my d cloud, is 16t to the third. Those are the four parts you're going to need, right? You're going to need rectangle and cloud prime. Then you're going to need cloud and rectangle prime. So if you go to put, when all we're doing is taking the derivative, we've already got our parts. All we have to do is put them back together again, right? So I'm going to do my first term, which is t cubed, times the derivative of that, times the derivative of my second term, which is 16t cubed, plus my second term, 4t to the fourth, times the derivative of my first term, 3t squared. Okay. Now again, when you're learning, you may want to literally write it like this. And then just bring the pieces in. Okay. Once you get good at the rule and you have the rule memorized, it's easier probably, and I know people don't like to write a whole lot, right? Once you have the rule memorized and you're quick with it, it's like boom, 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 just put it down. But until you've learned, you might want to write the rule and then fill in the parts. Okay? My point is this, look here, what happened. 16t to the 6th plus 12t to the 6th, boom, 28t to the 6th. Okay, so I didn't need to do that, right? I could have just multiplied it out and used the power rule, but I did, and it still worked because technically this is a product, right? I could break this a different way and I'd still get the same answer. It's a big waste of time, but I could do it. Okay. So you may be thinking, if I can avoid it, then why are you making me do this, lady? Well, because you can't always avoid it. So if you look at a problem like this, I definitely have a product here, but there's nothing I can do to simplify this. I can't combine this e to the x with this x cubed. This just is what it is. It's not going to simplify. So in this case, I have no choice but to do a product. So when I go to take my derivative, I'm going to need my rectangle, and I need my cloud prime, plus my cloud and my rectangle prime, or u, v prime, v, u prime. So let's go off to the side and find your pieces. If rectangle is x cubed, rectangle prime is 3x squared. If cloud is 3e to the x, then cloud prime is 3e to the x. So beautiful, so simple. Okay. So let's put our derivative back together. So I need my first term. I need the derivative of my second term, or the derivative of my cloud. That's 3e to the x. Then I need my second term, 3e to the x, times the derivative of my first term, or my rectangle, rectangle prime, which is 3x squared. So this is going to simplify just the tiniest bit. Now, if you're open-ended, I'm not simplifying that. If I'm on open-ended, I'm not writing this step. But if you are on multiple choice, this is probably how they're going to have it. Okay, so again, sometimes you can algebra your way out of the product rule. Sometimes you can't. If you can't, sometimes it's not worth it to do the algebra. Just do the product rule. It's not that bad. Okay. So this is another example of a time when you could algebra your way out of this, right? If you wanted to, you could distribute this 5x to the fourth, and then you would just have a polynomial on your hands. And some people will choose to do that. And go for it, right? I'm not going to choose to do that because I happen to like the product rule. So for me, I'm going to call this my rectangle, and I'm going to call this my cloud. So since I want to do a product rule, cloud prime minus cloud rectangle prime. Since I want to do a product rule, I've got to go find my two primes. So rectangle prime is going to be 20x to the third, just using the power rule. And cloud prime is going to be 6x plus 2, just using the power rule again, combined with the sum and difference rule. Notice how those rules come together. All right, so my derivative, when I put together the pieces, is going to be 5x to the fourth, my first term, multiplied by the derivative of my second term. Now notice, the derivative of my second term has two terms, so you better darn well put that in parentheses. Otherwise, you're not going to remember to distribute. Look what I did. No one's even going to yell at me. It's because I'm alone in my own house. That's supposed to be a plus sign. Oh, Britain. Tisk, tisk. Okay, now my cloud, 6x plus 2, again, put it in parentheses because you're about to multiply it by something, times my rectangle prime, so 20x cubed. Okay, so again, you can multiply this out and simplify if you'd like. If it's, again, usually they're not going to ask you to do a derivative this simple for no reason. This is probably going to be a situation where they want you to, might say like, where is this function have a horizontal tangent or something? So you'd be taking this, setting it equal to 0. Right? If that's the case, then you're going to want to FOIL it out. You're going to want to distribute and simplify it. If it's not the case, if you're not going to do anything with it, you can just leave it. You don't need to distribute or do any combining of like terms, unless you want to. Some people just like to do that for fun. Okay, now, when we think about how AP gets at these rules, like I said, usually they don't give us a derivative just for the sake of giving us a derivative. They usually make us do something with it. The other way they get at it, because they want to make sure we're not allowed to cheat with our calculators. I don't know if you guys know this, but there's a calculator out there called a TI-89 that basically just does calculus for you. You can say, hey, what's the derivative of this? And it just tells you. And they know that people have that. So they make it so that if you have that calculator, you don't have an advantage on the test. So that's nice of them. So what they do to get around that is they make sure that you know the product rule. And here's how they do it. Instead of giving you and telling you what functions are, they give you a table of values. And notice in this table of values, we're given a few choice values for a function f of x and also for its derivative at those same points. Same thing for g of x, a couple y values and a couple slopes or derivatives at that point. And then they define a new function, and that new function is h of x. And they define h of x as f of x times g of x in other words, as a product. So they're defining a new function that is a product of two functions, f of x and g of x. And they just happened to give you some information about f of x and g of x, but no information at all about h of x. Well, guess what? All the questions are about h of x. So it's our job to recognize that that's a product, and therefore we need to treat it appropriately when we go to take its derivative. Okay, so first question they ask us, what's h of 4? Okay, well, this is a pretty straightforward question. In fact, this isn't even a calculus question. If I want h of 4, that's equal to f of 4 times g of 4, right? Because h is defined by f of x times g of x. So if I can just go get these numbers, I'll be good to go. So f of 4 is 2, g of 4 is -1, and I come out with h of 4 being -2. Hope I didn't make any arithmetic errors. Okay, here comes the calculus. They say, oh really, well what's h prime of 2? I'm going to erase so I have a little bit more space to work with here. Okay, if I want h prime of 2, the first thing I need is h prime of x. And in order to get h prime of x, I need the product rule. You can't just take f of x and g, you can't just say f prime of x times g prime of x. That's not right. And what's interesting is people know that when there's an actual function in front of them, but for some reason when they ask this more abstract problem, I can't tell you how many times kids that I know the product rule, they look at this and they write h prime of x equals f prime of x times g prime of x. No, it doesn't. That's a product, and we have to use the product rule. So if I want h prime of x, I have to use the product rule. So that's going to be f of x times g prime of x plus g of x times f prime of x. And if you don't mind, I'm going to take a moment and rewrite that because I want to reuse it and it's really messy. So again, oh, come on. So h prime of x is going to be f of x times g prime of x plus my times f prime of x. Again, the first part of the function times the derivative of the second times the derivative of the first. Okay, so if I want h prime of 2, I have to go get all 4 values. So f of 2 is -1, g prime of 2 is 0. Ooh, that's lucky. G of 2 is 2. And f prime of 2 is 3. So this first part goes to 0, and the second part goes to 6. Again, you can bet anything that on the AP, if this is multiple choice, the answer you get when you just do f prime of 2 times g prime of 2 is going to be there, right? 0 will be an answer, because if you just take f prime of 2 and g prime of 2 and multiply them, that's what you get. They're going to give you that as an answer because they know it's a mistake people make. Okay, here's another example. So do yourself a favor. Pause the video and take a moment and do this one by yourself. Okay, I'll give you a moment to hit pause. Okay, you're back. Good. All right, so h prime of 4. Look, I already have my derivative here in just kind of generic terms. So if I want h prime of 4, all I have to do is plug in the numbers to my derivative. So I need f of 4, which is 2, g prime of 4, which is 3, g of 4, -1, and f prime of 4, -2. Okay, again, listen. If this is open-ended, for the love of all things, circle that. It's your answer, and you're done, and there's no reason to simplify it. I say that because if you come in here and you make an arithmetic mistake, you're going to lose your answer point. And on a problem like this, that's all there is. There's just an answer point. It's not that complicated of a question. So I'm going to come in here because I'm crazy, and I'm going to do 6, and then I'm going to say this is 2, and then I'm going to know that my answer is 8. But if I came in here and I said, oh, I'm -1 times -2, that's 3. Or -2. Or I multiplied this and got 5. If you get this answer wrong, you're done. You're dead in the water. So if it's open-ended, literally, I know it feels uncomfortable to leave 2 times 3 plus -1 times -2. Do it. What do they say? You have to get comfortable with discomfort or something. That's what they say. All right. Here's another way they ask the same stinking question. It's annoying. Okay. They are trying to get at this idea that the derivative and the slope are one and the same. So in these previous questions, they just flat out said, what's the derivative, right? Here, they're saying, write the equation of the tangent line. Well, you need 2 pieces of information to write the equation for a line. One is a point, which they said at x equals 7. So here's my point. X is 7. When x is 7, y is, 0. That's nice. So there's a point, and I need a slope, right? Well, what's slope? Slope is the derivative at 7. So in other words, I need h prime of 7. Okay. So here we go again. F of 7 is 0 times g prime of 7, which is -2, plus g of 7 times f prime of 7. Okay, so this goes to 0, this goes to 2. So I get a slope of 2. Now, look, if you want to do y equals mx plus b and write y equals 2x plus b and find the b, you go right ahead. I'm not doing that. I'm never doing it. I'm using point slope form. Y minus y1 equals m x minus, I can't write over my own face, hold on, x minus x1. Literally, this is all you have to do is plug in 3 numbers. It's quick, it helps you avoid making any arithmetic mistakes, and AP accepts it. It's a perfectly reasonable equation for a line. So y minus your y value, which is 0, and yeah, I'm writing it. Slope, which is 2, x minus your x value. Done, hands off, I'm done. If you don't want to write -0, don't write -0. But please resist the urge to simplify that. You don't need to bring if there's like a 2 here, you don't need to bring it over. You don't need to distribute. This is a perfect answer. move on. Point slope form. It's my best friend. We're buddies. Okay. All right. So listen, that's the basics of the basic part of the product rule. So I get a function, it's two chunks that I can't simplify, so I have no choice but to use the product rule. Okay? The more functions we learn how to take derivatives of, soon we're going to learn trig functions. So you could have something like 2x times the sine of x. It's a product. We're going to need the product rule. But we want to look at some twists on the product rule, like sometimes like things that might need simplified, or what if there's 3 things that are being multiplied or 4 things that are being multiplied? Like, what do? It's still a product, but there's more than 2 things. So we're going to look at some of those. We're going to look at the quotient rule, because of course it can't be nice either, right? If the product rule isn't nice, the quotient rule is not going to be nice either. And then after that, we're going to look at what happens when we kind of see all these rules combining. Like, what if I have a quotient and then there's a product in the numerator? Or what if I have a product and one of the things that's in my product is a quotient, right? And the rules kind of come together. So we'll practice some problems like that are more complicated. But for now, that's the basics of the product rule. And we'll get to the more exciting stuff soon. See you later.